Okay. So we'll be presenting improving access to satellite imagery using cloud computing. I'm Kate.
And hi, I'm Rahul. And the overall view is that we are going to cover the current problems with remote sensing, and then how cloud computing is helping us solve few of those problems, and how the data is accessible to now, and we can use this data to solve the problems. Earlier, it was only organizations which used to do that.
Awesome. So some of the current challenges in remote sensing are huge data set sizes, the availability, timeliness, data management handling, how much computational power it takes, and really that a lot of these data sets haven't been machine learning friendly. And one of them to focus on is data size here. So here you can see 5 different data sets. So OpenStreetMaps looks tiny on here, and OpenStreetMaps isn't tiny for any means. It's basically metadata for the entire globe. But some of these imagery data, like the one from Digital Globe or from the European Weather Forecasting Service, look huge. And to give really a context to these numbers, is we're talking in petabytes here. So that's 1,000 terabytes. Most computers cannot handle anything close to this. So we'll be talking about 3 different cloud computing services that have come forward that can address a lot of these issues that we put forth. First, we're going to talk about Earth on AWS. So run on Amazon's cloud computing service. It's accessible through command line if you have an AWS account, and used by many services, including Esri, Planet Labs, Digital Globe, etc. And then second one you might be familiar with is Google Earth Engine. So we use this in class, and it's used by many nonprofits as well. And it's particularly used by nonprofits a lot because it's free for research, education, and nonprofit use. And then the third one is NEX, which is the NASA Earth Exchange. And a huge problem with this data set is it's really only available if you're affiliated with NASA. And this is what's been used in the past a little bit more, but becoming a little obsolete because of the other two. So there's still some data sets that are only on NEX, you can see here. But many data sets are, like Landsat, are available now on Google Earth Engine and AWS. So this has made it widely more available. This means that these giant data sets, you don't have to download them all to your computer. You can get this information just bits and pieces at a time and run the computation on these cloud servers as well, which is a game changer for a lot of that.
Yeah. And so now onwards, we're just going to focus more on AWS Earth and what are the data sets available there. So can you guys see? So basically, okay, I'll just not point out, but so these are all the available data sets right now at AWS Earth, which is accessible to all of us. I can just give a gist about few. Let's say Landsat and Sentinel, those are high resolution images of the Earth from the satellites, and those are updated very frequently, and it's available to us through AWS Earth. And things like Digital Globe, this is like pre and post event mapping of risk events, let's say disasters and situations like that, and we get updated images in such situations. Terrain mapping actually gives us an idea of the elevation of the Earth at every point. And GOES. So GOES is actually by NOAA. NOAA is like National Oceanic and Agricultural Agency, basically. And you want to say some point? Aeronautical. Okay, sir. Thank you. So basically, they have recently launched this satellite GOES 16 in 2016, and we get data from that satellite too very frequently, right? So basically, these are the set of data sets available to us, and there can be a lot of potential lot of things that can be done using these data sets. We're going to focus at one of the data set and how it's being used currently to give a motivation to you guys, basically. So this is SpaceNet machine learning imagery. This data is available by private satellite, and what they have done is they have so just to give a gist of machine learning, which I'm sure most of you are aware of, is basically you get a data which is labeled, and you make a machine learn from the data so that it can further predict for the new data, same things that you made it learn for the given data, right? Example. So how SpaceNet is using this data? They want to improvise the machine learning algorithms. Let's say computer vision. They want to improvise the computer vision algorithm, so that we can detect things like roads and buildings with more accuracy, right? So they have, so these are the area of interest which are available right now in the data set. And if you look at this image, it kind of gives an idea that this is the image from the Earth and this is the ground truth. So for all the images, they have made the bounding boxes around the buildings so that you can train your model on that, and then you can predict, right? I'm going to cover 3 use cases on which how currently people are using this data set. So let's say start with object detection. From these bounding boxes, there are different algorithms which you can train and so as I mentioned, like machine learning, you train on the given data set and then you can predict the bounding boxes from an image. So this is an output of an object detection, which is drawing a bounding box around each building. Yeah, can you just go to the next slide? Thank you. So object detection, one thing, right? Second thing is semantic segmentation. In this step, what we do is basically we label all the pixels. So they from the training data that is available to us, we label all the pixels and then we group pixels with the same label as one class, right? So this example shows that they have labeled something as building and not building, and it gives us the groups from the image. And it is different. Yeah. And it is different from the object detection because object detection gives you bounding boxes which are parallel to the axis, and this can detect objects of any orientation. Yeah. Yeah. And let's say road detection. SpaceNet, actually just to cover a point, SpaceNet have this as challenges. So the earlier 2 problems that I showed were 2 challenges earlier, as like open challenges for the public so that you can participate and it's like an open challenge, you can earn cash. And this is the current challenge going on right now, which is road detection, which is, I think the submission is in coming February. So this is the ground truth, let's say, which is available based on the data set. They have mapped for these area of interest exact locations of the roads, and these are the metrics that they explain. So basically for machine learning algorithms, you have a metric on which you optimize your cost function. So F1 score is a metric which kind of looks at the width of the road, which is not the most important concern right now. The better concern is that you have to get all the links correct. So they have mentioned something like average path length score, which kind of penalizes if you are not getting the links correct. So these are the kind of use cases, and just to give an idea of how this will be used is let's say it's going to be like real time mapping of the globe, right? So if there is some disaster, you can look at the change in the infrastructure and detect there's some risk situation there, or you can update the maps very frequently and the roads very frequently for self-driving cars, and you can also get the gist of exactly which areas are really densely populated and things like that. So yeah, so this kind of gives a motivation of how this data set is being used.
Yeah, and so the first pixel, the one that's based more on pixels, you can see there in the purple, and there when you do that, you get the width. But really, what's paths are what is important. If you need to get an emergency truck somewhere, you don't really care about how wide the road is as much as if you can actually get there or not. So to close it off, I guess we have a little quiz, of course. And so, raise of hands, what are challenges of remote sensing that you guys think are addressed by cloud geospatial data? A. Okay, so we have like 70% of the class there. B. Okay, maybe like 50%, so we'll talk about that. C. 50% again, okay. D. Okay, a little bit higher. Cool. And E. Okay, a little less. Well, we actually said in some form or another, it's all of them. So obviously the first one we addressed a little bit more is that these data sets are really huge, and to download them on your personal computer is just not practical. But also the timeliness of available data. So because these are being updated constantly, you're getting this data more frequently, and also you don't have to keep downloading it to your own computer. Which is an advantage of it as well. Do you want to add?
No, yeah. For the E point, let's say machine learning friendly data sets, things like SpaceNet have labeled data sets, but not all the images that you get from satellite have labeled data sets. But still, they are designed in a way that you can access and run your machine learning algorithms or data mining and like hotspot detection, things like that on these data sets.
Yeah. So E is true, but there's a lot more to actually data sets that we need. This one is not enough. And then so for C, data management and handling, yeah, they're managing it for you, so definitely. And D, computation, because you can run it on the cloud servers and not on your own machine learning is really computationally expensive, and being able to do it basically on supercomputers is pretty helpful. Any disputes, questions? Yeah, Tim?
Yeah, are any of these free for students?
Yeah,
or
so-
really cheap?
Yeah, so by the way, AWS is not expensive, it is cheap, and it's for students, you kind of get an account. Plus, I mean, if you explore, yeah, but if you explore Google Earth Engine, it's free.
Yeah.
Yeah, but you have to request an access.
What?
Explore.
If you use Google Earth Engine, so we use that for our lab, and you can continue to use that for free.
AWS is also pretty cheap. I think it's
Yeah, compared, well,
And it's both data access and CPU.
computation. Yes, correct.
Okay. Has anyone used these things?
This is by the very new AWS Earth, and like there are a lot of researchers who obviously use this, but
I've used AWS in general, but not specifically their data sets. And then, I mean, yeah, we all use Google Earth Engine, so. And I played around with it a little bit
Yeah.
for this project, but not extensively. Yeah, and so this is additional sources. Any questions on the presentation as a whole? Cool. We either explained it really well or really badly.